we shall continue the discussion further on the fundamentals of digital electronics as required for detailed understanding of the subject Arduino. So this is the concept of the first building block of gate and other is buffer, tri-state is presumed, just like when we say gate, we presume that it is a logic gate and not the gate of building. So gate and buffer and to understand it, how it works by emulation. Emulator is just like imitates, copy. Emulating means whatever is the function, operation of the gate is emulated by human being. So a human being emulates the working of gate and is explained to everybody in the manner in which that human being should work if that entire arrangement to behave as a gate. Instead of this now, there can be a non-living entity, an atomized gate. Instead of this, there is a non-living entity, atomized gate. I repeat, one thing is very clear, which you should remember very clearly, that if you are able to do something, then it is possible that it is not impossible. Something which you can do can obviously be done by somebody else, and that somebody else may be an individual living servant or a non-living servant, like some kind of arrangement using semiconductor devices. So that is very important, number one. Number two, since you have come from a very competitive environment, you must be very much curious, and few students ask me on WhatsApp what material we should refer for this subject. I will have to state that you don't refer any material except what I put on the group, because there is a chance that there may be confusion. As regarding teaching learning process, I am having a typical out-of-box thinking mindset which does not match with the others. Maybe either I am too exceptionally brilliant as a genius or exceptionally fool, that it is for you to judge. But the only thing is that at least till this month or till when I tell that you should watch this, you should read this, don't read anything, only watch what I say, only read what I tell. Because I am confident enough that it is now embossed upon you that you will not be able to forget even if you want to forget. That is the development, academic development and value addition of an individual, irrespective of his desire, is aim of a teaching institution, that of the teaching learning process. Means I should thrust upon. See, when we talk of mass learners are generally reluctant. This is to be assumed by a teacher. Blaming students that they don't give attention, this is something which is universally true in time and space domain. At the time of your grandparents also, their teacher was saying that nowadays students are becoming more casual. Now also they say, and now in India they say, and in US or in Walchand College, as the teachers say, likewise in MIT USA also teachers say that students are not serious. So a serious student is a paradox, something which is impossible. A person who is serious can't be a student. A person who is a student can't be serious. We can't assume that a serious student, you are teaching to a serious student. You must be able to organize your contents in such a manner that even a casual student, only thing is that he simply should listen, and once he listens, he must understand on his own. I give you an interesting situation that it is said that Abhimanyu learned something when he was a fetus. What his mother was uttering, being fetus, There is no question of he attending or not. Just it is being bombarded on his ears, and once it is bombarded, it has to have an impact. Like that, I am trying my level best to arrange the content so that there should not be a scope for not understanding it. So that I repeat again. So with this now, we proceed with a logic gate. I will explain some other things, and a tri-state buffer. So I am rubbing it out, but you can anytime go back and watch. When you want to revise, then using this YouTube technique, there is a very simple logic which you might be also, what we can say, experimenting. That you can run at 2x. For first understanding, you run at normal 1x speed, and once that is known, you want to recap, you can play the YouTube, you can play the video at double speed. At 4x speed would be what we can say mockery, but 1.5x or 2x speed is something which you can very easily cope up and finish your revision. Now, even though we are not in a common class where I am asking something and an opportunity is there for you to answer, what you can do, there is always an opportunity when I ask a question, you can pause. When I ask a question, you can pause the video, think on your own whether you are able to answer the question. If yes, you prepare the answer in your mind. If no, watch the video. If you have prepared the answer in your mind, then resume the video and check whether the answer which you have thought is correct or not. Okay. So now, there are two types of digital circuits. One is those which do not gates are essential. Without gates there is no point of digital circuit. Two types, those without buffer and those with buffer. So the circuits which do not use tri-state buffer in them, every output at every means there is a gate. At the output of the gate, you are an individual. You put the switch to position 1, that is 5 volts, or put the switch to ground, that is 0 volts. So every output of a circuit which does not consist of buffers is either logic 1 or logic 0. And if a buffer is there, in that case the output can be either logic 0 or logic 1 or tri-state Now here I would like to ask a very interesting question. I am sure that it is a very difficult question. It would be not so easy for you to answer, and I would be happy if proven wrong. The question is, there is a circuit, a big circuit which includes many gates, many buffers, and one test output T has come. The circuit may include buffers, may not include. So the output can be either logic 0 or logic 1 or tri-state. The output can be either logic 0 means I am talking of a circuit which includes gates and buffers and one test output. That test output can either be logic 0, that can either be logic 1, or that can be a tri-state. The question is, how, before that, if there was a circuit which does not include buffers, then how you check the output? You have LED. If an output Y is there and it does not include tri-state buffer, output logic 1 or logic 0. So you have an LED, this is called as test probe. LED, you put it to ground and you connect it here. If LED glows, then the output is logic 1. If LED doesn't glow, then the output is logic 0, because output cannot be at any other state than plus 5 volts or 0. Then one will say, also you try to think on exceptions. It is extreme, you don't take it as a sarcastic, negative, extremist view, but exceptional thinking. If LED probe is given to you, and you are using the LED probe to test something, what is first requirement? Suppose if you want to check, you are having a dieting plan and you want to check your weight, and you go on a scale and you check your weight. It gives some reading. Is it okay? No. First of all, the weight scale should be working. So a standard weight is to be put and checking is to be done. After again a standard weight is to be put, means a standard weight of 50 kg, take the reading, you be on the scale, say 65 kg, then again put the standard weight 50 kg, then it's okay. Like that, the first what you should do, that LED probe, there is a +5 volts in the system. And yeah, so first you should put it here, LED must know that LED is working, then you should put it here, take the reading, then again you should put it here, LED must work. So if with this LED glows, output is at logic 1, if LED doesn't glow, output is at logic 0. So using just first, if a good LED is there, a good means this is just to check the working status. A working LED probe will glow if output is 1 or high. It is set as high or 1 and low or 0. For a digital circuit which does not include buffers, the working LED probe will glow if output is high, or output becoming high means if LED probe glowing means output high, LED probe not glowing means output low, right? But now here we are at an output which is having a tri-state capability. And now what will happen? A good LED probe you connect. A good LED probe, when you connect from the test output anode, obviously it is, I did not mention, it is presumed, anode to output, cathode to ground, LED glowing, output logic 1. So LED glowing, output logic 1. Then LED not glowing. If it is here, it will glow. When LED will glow? If initially at the beginning of last lecture I told that when LED glows, if anode is at +5, cathode is at ground. If cathode is at ground and anode is hanging, LED doesn't glow. If cathode is at ground and anode is also at ground, LED doesn't glow. So for position 1, when switch on position 1, LED will glow. When switch on position 2, LED will not glow. When switch on position 3, LED will not glow. So in testing, if output is logic 1, you can conclude immediately, yes, LED glows means output logic 1, because LED glows only for one position, whereas not glowing leads to 2 positions. Even if the output, that is the switch that is at position 2, is one pole 3-way switch, either here or here, LED doesn't glow. So what is the conclusion? How? This is a big question, and those who are able to answer this question should find themselves to be very much privileged students. They should be proud of themselves. Now, so connect means the test 1, that is anode to output, cathode to ground, LED glowing, output high. LED not glowing, we are still unable to conclude. And when means you take first reading, based on first reading you get the answer, that's okay. But if on first reading you don't get an exact answer, there is need to have some second reading. What is given to you? Only thing available to you is a circuit which is having plus 5 volts, ground, a circuit, everything inside, one output pin, plus 5, so a circuit having 3 pins, supply, ground and output, and an LED glow. So first reading we have done, LED glowing, yes, LED not glowing, problem. So what kind of second reading you will take, and you can pause, think on your own and then resume the video. Since only one LED probe is given, so what I do, and cathode. So first reading, you connect LED T to A, ground to cathode, setup 1. In setup 1, what will happen? In setup 1, LED glowing, output 1. Not glowing, you can't answer, question mark. Now you go for setup 2. In setup 2, what do you do? In setup 2, you connect anode to VCC or 5 volts and cathode to output. That is plus 5 volts to anode and output T to cathode. This is setup 2. Now what will happen? If output is logic 0, means LED is like this. If output is logic 0, cathode 0, anode 1, or cathode 0, anode plus 5 volts, LED will glow. So in setup 2, LED glowing, output, if it is glowing, output is 0, and if it is not glowing, then it is tri-state. So here it is, in the first setup, it is either 0 or Z, and in third case, in setup second, it is tri-state. So if this is outlet 3, LED will not glow between this, means if we connect LED from this to this, setup 1, for output at tri-state, this will not glow, this will not glow. So if we put setup 1, setup 2, in both case not glowing, output at tri-state. If glowing in setup 2 glowing, output 0. Setup 1 glowing, and LED cannot glow in both cases. Impossible. Means you can't have LED glowing here. If it glows here, it can't glow here. So can have two experiments, 0, 0. You can have in general two experiments, 0, 0, tri-state, 0, 1, logic 0, 1, 0, logic 1, 1, 1, impossible state. This is something which is extremely important understanding in digital electronics. So, what is the big advantage of tri-state? Why we are going for all these things? We are going for all these things, as I told you in the previous lecture, that I want a very long piece of paper, but I want to watch it only in viewing window. So an A4 size viewing window, I should be able to access a huge paper. So at a time, only required thing should come in the window. So I want to access means, suppose if there is I will explain in detail about memory cell and all these things in next lecture, but prior to that, there may be many multiple inputs. A very big circuit which is giving me 4 outputs, and for me inside there are very large number of small circuits, but I want to take output only on one pin. I don't want these many pins to come out. If these many pins come out, it becomes bulky. If I don't go for a notebook and I stretch the entire paper, it is bulky. So I should be able to either connect this here, this here, this here, and this here. And this is possible if and only if all these outputs, what I do, I connect all the outputs together. Remember, I shorting all the outputs. Then this would be very disastrous. You can short all the outputs if and only if you take care when you short multiple outputs, when there will not be any disaster. Number one, that all the outputs which you are combining must be having an ability to be working in tri-state, and at any given point of time, all except one must be in the tri-state. If this output is active, all these three must be in tri-state. If this is active, all these must be in tri-state. So you can select which output you want on the common pin, and that after that selecting, using just like you can using page number, you can go for required page on a very huge piece of paper by folding it. So like that, you can select it. We will discuss it in the next lecture. Thank you.